Hello, my name is Richard Hogan. I'm an external student for the University of Southern Queensland, currently studying the MEC 2406 Introduction to Mechatronics, and today I'm going to talk to you and demonstrate to you my second assignment. It's about a flying fish that we had to develop with proportional, integral and differential control. There were some challenges involved, namely aerodynamics and external forces applied to the fin and the wing section that is difficult to control, to say the least, because it in itself has some form of feedback and can be unpredictable when it comes to turbulences and pressure drops. So with the entire system, I adjusted the integral control with a little bit of overshoot to help get the fin to the right position. And the differential then helped to dampen out any additional pulses. It increased the damper ratio, if you will, to help bring the fin under control once it got to its position and stabilise there. So having said that, I'll now go ahead and do the demonstration for you. There are a couple of key things that I did overcome, but we'll get to the demonstration now. So here I'm performing test 1, where after the initial calibration it will be preset to a set point of 0 degrees, and then at 41 seconds, which is 10 seconds after it's finished its calibration, it will switch to a -5. So there we go. -5 degrees is the set point after 10 seconds. Now I've chosen 3,000 iterations. There you go, there's the -5. I've chosen 3,000 iterations to do the averaging because it ran at a negative bias. And the negative bias I've cancelled out with an if function from -0.6 to 0.3 degrees. I've told the system to be 0. Now you can see as I'm moving the fan around, the fin itself responds to keep a constant angle. There's a little bit of overshoot from the integration, but that's to compensate for the air pressures and flows and turbulences flowing across the fin. With the slight interaction, you can see that it adjusts itself with a slight overshoot. Now I did try to adjust the overshoot out, but I found with the frictions of the bearings and a little bit of resonance feedback from the shaft and the looseness of the bearing. Now here I'm just commencing test 2, where the setting is preset to 5 degrees fixed, and then we continue to move the fan around. Now going back to the resonance, there was a little bit of interference, so I opted to give it a little bit of overshoot to help combat that resonance from the mechanical interference. So here it's just recalibrating itself. You'll see a little bit of interference at the start, but after it's recalibrated, it's gone straight to 5 degrees. And now as I move the fan around, you will see that the integration and differentiation part will actually pre-adjust the fin to set it to 5 degrees. Now as I said, if we tried to give it just a proportional control, it'll never actually get to its final angular setting, because the error subtracted from the proportional input would give it a 0 output. So what we require is information from past feedback, which is the integration part. But if you have too much of that, it can give you too much overshoot, and sometimes if you don't have enough damping ratio, then it will continue to oscillate. So this is where we actually introduce a differentiation which tries to predetermine the future, and it predicts where to start to walk the signal off in an effort to try and get it as close to 0 as possible without overshooting. Now as I said, with this demonstration, there we go, a little bit more input, and you'll see how the fin moves around and stabilizes the whole wing. So, but as I said, with the differential feedback, it gets it as close to its set point as possible without nullifying the actual input signal. So early on in the piece, I'll just quickly mention that I did have some issues with the gyroscope accelerometer calibration, because I initially had the accelerometer mounted 40mm forward of the pivot shaft, which did put my scale out. Now I ended up moving the shaft forward because of mechanical advantages and some issues that I had. So after moving the shaft forward and putting the pivot straight over the accelerometer, it fixed my scaling. But I got everything set okay, and it seems to be functioning quite well as it is there now. So I hope you've enjoyed this video, and yeah, everything as far as I can see turned out quite okay.